Absolute value equations. Absolute value is what we're starting with today, okay? And I need you to remember what absolute value means. How much a number is from 0, how far away it is from 0, the distance from 0, those are all good. Okay? Those are all very good. So let's start off the easiest possible example I can give you. Well, I guess it's really the third easiest possible example I can give you. Because the easiest would be if I made it equal to 1. But we're going to go with 3 because, yeah, that's why. Okay? So, here's what I need you to trust me on for this. Okay? I'm going to show you a way to do this. It's not exactly the way it is in the book. Not that I'm right and the book is wrong. It's just a little different way to think about it. But I know where we're going. And when we get to absolute value inequalities, which is what we get to next, okay, we're going to do absolute value equations for a couple days, and we'll do absolute value inequalities for a couple days. If we'll do it the way I do it, absolute value inequalities will be way easier. Way easier. Okay? So if we do it the way that they do it in the book, you kind of have to think a little backwards and forwards and upside down when we get to inequalities, and I would just regular think. Okay? I mean, I try most of the time to do that anyways, but you know what I'm saying. Okay? So trust me on this one for now. When we get to inequalities, you'll see what I mean, I promise. You just got to trust me on it for now. Okay? So the first thing you're going to do, we're going to write some steps over here that we're going to use to solve every single one of our absolute value equations. Okay? The first one is isolate the absolute value. Oh no. Isolate the absolute value. Okay, done. It's already isolated. It's all by itself. There's nothing being added, subtracted, or multiplied, or divided to this absolute value. I'm not talking about inside. I'm saying just to the absolute value itself. Okay? Next thing we're going to do is write it in 2 parts. Well, why would we write it into 2 parts? In this point, what is inside the absolute value? What is it allowed to equal? It could be either 3 or -3, right? Because whatever's inside, when I take it out, it's going to be equal to 3, right? So I know whatever's inside can either be positive or negative. So I'm going to have 2 parts, one being positive and one being negative. Okay? So here's how we're going to write this. There's the positive one. And there's the negative one. Now, are these parentheses necessary right now? No, but I know where we're going. So trust me on that. When we first write these, we're going to write them in parentheses. Okay? Now, this is pretty obviously x equals 3, right? It's pretty obviously the answer. What do I do with this to solve it? How do I solve a negative x equals 3? Yeah, divide by -1. X equals what? -3. Isn't that what we said to begin with, that the answers would be 3 and -3? This is the mathematical argument that proves those are the 2 answers. Okay? Now, on your homework today, you're also going to be asked to graph the answer. So at first that seems like, what? Except you realize there's only an x, there's no y's, so we're not graphing it on a coordinate plane, we're graphing it on a number line. Well, there's 0, there's 3, there's -3. Where's an answer? At 3, right? There's an answer. Where's the other answer? -3. Done. Again, this is not going to be one of those things that make total sense until we get to inequalities. So we're just practicing our graphing skills, number line graphing skills right now, because it will be really, really helpful when we get to inequalities. Okay? So just trust me for a couple days to get through this. Can you do that? Okay. So what about something like this? Absolute value of x plus 4 equals 9. What do you think about that? You have to subtract 4 from each side right now? It's a good guess, but can we take stuff out of the absolute value sign? No, we can take stuff away from around the absolute value sign, but not from inside. So is the absolute value isolated? I forgot to finish the steps. There's one more step. Can I write it real fast? First step is isolate the absolute value. Second is write it in two parts. The third one, solve and graph. So, is the absolute value isolated here? Is the absolute value all by itself? Yes. Okay. I know there's stuff inside the absolute value. I don't care about that. Is there anything being added, subtracted, or multiplied, or divided to the absolute value? No. So it is isolated. So now I need to write it into two parts. The first part is when it's positive on the inside. And the second part is when it's negative on the inside. Does that make sense? Okay. Now what? Now we do the minus 4, right? Subtract 4 here, subtract 4. Is it okay that I'm kind of ignoring those parentheses? It is, right? Because parentheses x plus 4 is the same thing as x plus 4, right? Okay. So now I have x equals 5. What do I do over here? What do you want to do? You want to divide by negative 1? Okay, I can do that. X plus 4 equals negative 9. And then if I subtract 4 from both sides here, I get x equals negative 13. Is there another possibility of something I could do from the very beginning? Couldn't I just distribute that negative sign in there? Can I show you that that works also? Okay. This is not another part. I'm just showing you something real fast, okay? If I distributed this here and here, I get negative x minus 4 equals 9. If I add 4 to both sides, do the opposite sign of that, I get negative x equals 13. Then I have to divide both sides by negative 1 and get x equals negative 13. I got the same answer, but just more steps. So is it wrong to do it this way? Absolutely not. Okay? We get the same answer doing all the correct math. Just has more steps. So if you want to do it this way, great. If you want to do it this way, great. Just do it one of the ways. Okay? Now I have to graph, right? Before I graph though, there's one more thing that I really should do. Before I graph, there's something that I should do. I should make sure that the answer is right. How would we do that? Plug it back in, right? I substitute this back into the equation. So if I put this in, I get 5 plus 4. 9. That took way too long. You're scaring me. Okay, 5 plus 4. 9. Okay, good. Absolute value of 9. Does 9 equal 9? Okay. Negative 13 plus 4. Negative 9. Absolute value of negative 9. Does 9 equal 9? Okay. So here's the deal. Did I just check that problem? Where's my proof? Did I write anything down on my paper that says I checked the problem? A lot of times, you know what I do? I literally check the problem. It's like a inside my brain thing that tells myself I checked it. Now, I know that mathematically I'm talking about putting a number into a problem and making sure it works. Physically, I'm talking about writing a check mark beside the problem because that tells me, my brain, that I checked it. Do you have to do that? No. Could you write it down? 5 plus 4 equals 9? Yes. Somehow I need you to check the problem. Because the best part of that means you're never going to get it wrong. Because you've already checked it and you know it works. Now I need the graph. Okay, do you want to see a good example of a graph or a bad example of a graph? A good, okay. If I want a good, there's 0, there's 5, there's negative 13. Why is that a good example of a graph? I've got my 0 for sure. Do I have the 5 on the correct side of the 0? Do I have the 5 and the negative 13 an equal number away from 0? No, because they're not, are they? Okay, this one's further away. All those things, if you don't do them, that's what makes a bad graph. Putting the 5 on this side. Not putting the 0 on there. Putting these an equal distance away from 0, unless they are, like those were an equal distance away from 0. That's because they are, right? These aren't, so don't put them an equal distance away. Okay? Now, last period they asked me about putting the numbers in between. Because like on this one, they wanted the 1 and the 2 and the negative 1 and the negative 2. I mean, you can go right ahead and do that. That doesn't bother me at all. But this is also okay. Okay? I'm letting you get away with a little bit of a shortcut. Are you all right with that? Okay? It's not wrong. You just don't have every single one of the dashes, and that's okay. Any questions? Okay. Oh, I'll do it on another page. That's fine. Stop. Silly paper. Oh, let's use purple this time. 3, absolute value, x plus 1 minus 6 equals 9. What's our first step? Isolate the radical, right? How do I isolate the radical in this problem? What do I do first? First, how would you solve this problem? How would you solve that problem? I'd add 6 and then divide by 3, right? How is that any different than what we're doing here? It's just that this is what we're considering our x right now, right? So we're doing the same things that we did on a problem like that, the same kind of order, right? So let's add 6 first. 3 times the absolute value of x plus 1 equals 15. And then, God bless you, then divide by 3. Absolute value of x plus 1 equals 5. Is the absolute value isolated? Yes. So now what? Yep, 2 parts, right? 1 positive, x plus 1 equals 5. 1 negative, negative x plus 1 equals 5. How do we solve the left one? Subtract 1 from both sides. X equals 4. How do I solve the right-hand side? Divide by negative 1. X plus 1. Oh, I don't need those. Sorry about that. Equals negative 5. If I subtract 1, x equals negative 6. Now what? Check it. Okay. 4 plus 1. 5. Absolute value of 5. 5 times 3. 15 minus 6. Is it right? Negative 6 plus 1. Negative 5. Absolute value of negative 5. Times 3. 15 minus 6. And now, graph it. 0, 4, negative 6. I could have put my negative 6 a little further away. Sorry. You'll do better though, right? Good job. Negative 6, positive 4. Any questions? All right, let me show you one more. Absolute value of x minus 6 plus 3 equals 2. What do I do first? Isolate it by subtracting 3 from both sides. Absolute value of x minus 6 equals negative 1. Is the absolute value isolated? So, 2 parts. X minus 6 equals negative 1. Negative x minus 6 equals negative 1. add 6, x equals 5, divide by -1, x minus 6 equals 1, add 6, uh-oh, what'd I do? Do you see my error? Anybody see it? It's right here. If I divided, oh no, that's right. Oh, no, look, this divides by -1, so I just get x minus 6, don't I? Okay. X equals 7. And now? Check it. Okay. 5 minus 6. Absolute value of -1. 1 plus 3 is 2. Did I mess up? Okay, so maybe just not that one, okay? All right, 7. 7 minus 6. 1. Absolute value of 1. 1 plus 3 is 2. So let me give you a hint. It doesn't work. Yeah, that's not really a hint. That's just repeating what you said, right? Here, let me give you a hint, though, for real. Okay? When I got to this point right here, I could have stopped and written no solution before I did any of this stuff down here. Can anyone tell me why I could have stopped right there? Can I ever take the absolute value of anything and get an answer that's a negative number? No. No. I can start with it. This could say -2 right here, right? Now, it still wouldn't work because I'd be subtracting 3 to get a -5. But if I was subtracting 3, so I'd be adding 3 to both sides, that would work, wouldn't it? So don't just automatically assume because it says equals a negative that I can't do it. When the absolute value is isolated and it equals a negative, there's no solution. There's no number that I can take the absolute value of that's going to give me a negative answer. Does that make sense? Okay. Last period they asked if we needed to graph it. So I just did this. There you go. There's a number line. There's no numbers on it. I could put a 0 on it, but there's no solutions on it, right? There's no solutions on that number line, is there? Okay? Any questions about this?